Welcome, software engineers. This is day 22 of CSC 222. I like those 20. Hey, it's November 2022 also. Thanks for being here. I appreciate you joining and connecting on time and being ready to go. Boss, Carol? Carol's the admin assistant. I'm promoting you to engineer. I have no engineering background. I can't find anyone qualified, and I don't want to lose the head count in the next budget. So just fake it. I'll ask Dilbert to train you. It does look easy. What a working professional finds funny about this is it's really true. When you have a budget, if you don't spend all of your budget, you don't get praised for that. They take money away from you the next year. So if you're supposed to have 12 people in your department, you only have 11, you're not actually helping anybody. You need to have that 12th person. So you hire Carol to do our job. That's good. You know, I don't even have to remind you anymore that we can describe software engineering as professional problem solving. We're taking a look at aspects of professionalism. Last time we began my 8th aspect of professionalism, being respectful. Yeah, and Catbert's always pranking the boss here. Didn't you advise me to show interest in my employees? Ah, they hate that. Being respectful is a mark of a professional. Just as the 10 Commandments can serve as a framework for how anybody, and especially Christians, would live their lives in an outward way, the 8th commandment, you shall not give false testimony against your neighbor. Now, don't forget, that's the easy thing to remember. It's also the easy thing to point out when something went wrong. But I am just as interested that you can spin it to its positive perspective. And that's how Luther did when he explained all the commandments. So be sure to look. Do I have that next? We'll see. If I don't have it next, we talked about it last time. And take a look at the positive aspect of what that means. Yes, don't give false testimony. And yet, at the same time, in addition to being respectful, the 8th commandment also, and professionalism, can also deal with how we accept advice from other people. And that is a hard thing to do also. Accepting, apparently it's hard to say too. Accepting advice is sometimes hard to do. You could probably see how this relates to being a team player also. Oh, good. We don't have to guess. Look, but what does the 8th commandment mean? Defend our neighbor, speak well of our neighbor, and explain everything in the kindest possible way. So in the CNC assignment, think in those ways. What does it mean as a software engineer? Defend, speak well, explain everything in the kindest possible way. By the way, this does not mean to fake it. Oh, sure, boss, we're going to be, no. But when you do have to say something, don't automatically spin it in a negative way, but think about it. I shared with you at one point along the way that when you send an email message, the odds of that email message being forwarded to who knows who are sometimes very high. So just watch how I try to remember this myself. Watch how I'm phrasing this. Think about what would happen if somebody forwarded that to a third party. Some upcoming assignments. Now, as I mentioned last Wednesday, this Wednesday, November 9th, you guys at Irvine are celebrating Veterans Day. Good for you. I'm glad to see that. Unfortunately, Mequon doesn't celebrate Veterans Day. The actual day is the 11th, so I'm not sure why you're doing it on the 9th. Maybe just to get out of this class? That's good. CNCS9, though, it says Wednesday, but I don't want you to have to work on a day off. So it's due on Thursday. This Thursday, November 10th. And that same applies to assignment 17. Assignment 17 that you've seen for more than a week is this next sprint on the individual project, the add numbers project. If you have questions about that, feel free to ask. And it's also fair for you to, in your team, now this assignment 17 is not a team project. It is an individual project. So I don't want folks to just grab code from somebody else and claim it to be their own. But it's fair to ask questions. That's okay. Maybe you'd feel more comfortable asking somebody who's a peer on a team, hey, what's this mean? Or give me some hints on how to do that. That's fair. Originally, when I signed it a week and a half ago, I said this Wednesday, but again, it will be due Thursday. So CNCS 9 due Thursday, assignment 17, the individual add numbers sprint 5, I think we're up to, is due Thursday. Two new things that you're going to see today on Blackboard. Assignment 19 is due not Wednesday, not this Wednesday, but next Wednesday, the 17th of November. Assignment 19 is an idea document. What I'm going to do is I'm going to combine the requirements and the specifications phase into one document. And this is that document for the team project. Every team now has selected a project. Good for you. And, I should show you what they are. Probably not ready for that. There's only a couple teams that chose the same one. There's good diversity there among the projects, and a couple ones that were selected that I'm thankful for. I think they'd be great showcases for your capabilities. Assignment 19 then asks you as a team to think about the problem, think about the requirements, and think about the specifications. Meet as a team to discuss and hash this out and brainstorm, but then only one person on the team needs to actually collect all this data and produce the document. You can decide how to divide that up. Assignment 19, there's some things online at Blackboard. I'll say a little bit more about it later today. And certainly if you have questions, ask away. But I'm going to encourage you to go back to Unit 1 and review those things we said about a problem definition document, a requirements document, and a specifications document. This idea document are those three things all together and somewhat simplified. You can do a good job, I believe, in just a few pages. It'll be different depending upon the different projects, but this is not a 10-page research paper. That's really not even 5 pages. I'm sure you could do a good job in 3 pages or a little less than that. That's assignment 19. Assignment 20 then, also due next Wednesday, not this coming Wednesday, but Wednesday, November 17th, is the first sprint of your team project. At the end of what's today? At the end of last Wednesday's session, I showed you we'll be doing 3 sprints with our team projects. And the first one is due, the first sprint is due November 17th. Now, let's review. What's a sprint? It comes from the Scrum implementation of the software development lifecycle. Scrum is an agile method. Scrum wants folks to not do everything and think about the entire project at once, but produce subsets in what Scrum calls a potentially shippable product. So you're not making a prototype. You're not making a proof of concept. You're not making something that's only half baked. This thing will work. It just doesn't have all of the features and functionalities. Now, as a team, you'll decide what features and functions will this first sprint have. Here's my caution. First of all, I encourage you to do the hard part first. But secondly, there'll be 3 sprints. And by the time you complete the third one, you need to have everything. So if you just have 10% in the first sprint and another 10 in the second sprint, you got a lot to do in that last one. The general heuristic, as we've seen a couple times, is hard part first. Everybody phrases this differently. I mean, I haven't heard this too often, but I was discussing this with some software engineers, and the phrase came up, eat the frog. If you have to eat a frog, and no, we don't want to, some frogs are poisonous, but if you've got to eat a frog, do it the first thing in the morning. And that's the idea. Hard part first. You identify, oh man, this is going to be a little difficult. Focus on that first. So, as a team, you get to plan these. Here's when they're due. So, sprint 1, as I mentioned, next Wednesday. Sprint 2, November 30th. Just to recognize that that prior week is Thanksgiving week. Okay. And then the final one, I know the 14th of December is in the midst of the final exam week. We are not meeting explicitly that week. I don't think. I gotta think about that. But that's the final, it's not only the final sprint, it's also happening during the final exam week. So as a team, you can decide, here's the features we're going to do for sprint 1 and 2, and then everything in 3. Any questions or concerns right now about, either these 2, 19 and 20 upcoming assignments, or figuring out the sprints? While you're thinking, if you can't tell, my background is the Oval Office, and you're wondering why I'm in the Oval Office, it's just to remind you that tomorrow is Election Day. I'm sure other people have reminded you. I forgot to do that last week. I got to think about California. I haven't been in California in a long time. In my home state right now of Wisconsin, you could register to vote on Election Day. I would encourage you, and as a student, you can either vote absentee wherever your home is, or you can register to vote in the precinct at the university.
Is this one?
Comment or question? No. Okay. All right. When questions come up, and when I notice I said when, I really don't think that any team has all of the information needed to understand any of these projects in the depth that's needed to create them. So when you get to the point where you're meeting, feel free to send me a message. If it's easier, we can Zoom at an appropriate time and what have you. So a little bit more than a week ago, we began Unit 3. Unit 1 was idea. Unit 2 was implementation. Unit 3 is interaction. Excuse me. Unit 3, interaction. Another way of thinking about it is this is the power of the product. What good is an app if it can't be used to solve problems? Or alternately, if it isn't used to solve problems? The whole goal of software engineering is to create an acceptable product. And the purpose of that product, like the purpose of software engineering, is to solve problems. In the interaction unit, there are two additional major phases of software engineering. Previewed those last time. Today we'll actually begin our discussion. We're going to begin with the deployment phase. So in our listing of phases of software engineering, this is the fifth phase, deployment. What's that mean? Well, last time I told you in the deployment phase, this is when the user receives the product and employs it to solve a problem or executes it to solve a problem. From a designer's point of view, this is when we release it. We let it go from us to the client and user. Another way of thinking about this is my product is now put into production. So deployment. This is the phase where the user is going to execute, employ, use, or run our product. It's gone from us, developers, to our clients and users. It's moved from a development environment to a production environment. All right. So here's the definition that I shared with you last time. Very succinctly, software deployment includes all activities ensuring a software system is available for use. We're going to see today, there are a number of things that software engineers need to think about before and during software deployment. All the activities ensuring, note, a software system is available for use. In the distant past, I one time mentioned the concept of informatics. Here in the United States, we usually call the discipline we're involved in right now computer science. But in other countries, especially Europe, computer science goes by the name informatics. And I like that name because it emphasizes something. What is a computer system? Fundamentally, a computer system is comprised of three components: hardware, software, and here's where some computer scientists get stuck. What else is there besides hardware and software? Answer: people. A computer system is a combination of three components: hardware, software, and people. Informatics has various definitions. One way I phrase informatics is informatics uses technology, hardware and software, to solve problems for people by focusing on the user experience. Informatics uses technology, computers, hardware and software to solve problems for people by focusing on the user experience. So we've talked a little bit about that previously. Not just a little, we've actually talked about that a lot. Requirements and specifications, all about people. And even in our implementation phase, we were concerned about other people, even though they weren't users, we're concerned about other developers. And now in our deployment's not the final phase, but now in this last aspect of interaction, we got to go back and focus on people and the user experience. So, what are the tasks that are necessary in deployment? Before we even look at any of those, can I remind you, software engineering is the management of the entire software development process. Managing requires a plan. You don't have a plan, you're not managing, you're just making stuff up. As with all the other phases of software engineering, for deployment, you've got to plan, think, write, do. What do we have to plan? Number one, production. Would you pardon me just a minute? Don't go away. I'll be right back. Gotta do one thing. There, that's better. Thank you. Production. You can see how this is important in a hardware world where you have something like an assembly line and it needs to produce GPUs or something. Production is also an aspect of software. You're saying, no, I created in Visual Studio, there it is. Yeah, not exactly. The odds of you giving to an actual user directly what you created in Visual Studio, not very high. Production requires planning. Distribution. How are you going to get your product to the customer? How are you going to get your product to the client? You're saying, well, that's dumb. We'll just send it via data communication. Yeah, maybe, maybe not. Take a look at the notes for today. I fleshed this out a little more, but let's list a couple of them and then let's really focus on one of them so you can see, yeah, there's a lot to think about here. Production, distribution, marketing. Now, remember that there are several different ways to do software engineering. There's the problem model and the opportunity model. We're following the problem model where somebody came to us and said, I need an app that does this. But if you're involved in the opportunity model, then you're going to create this and you are then going to hope that other people buy it. Well, how are you going to let them know? That's marketing. I want to pause a little bit on this fourth one. For deployment, you have to plan the licensing of your product. Let's review this concept of software licensing and see what the big deal is. You ready? All right. So, if you don't already know, software is hardly ever sold. In general, software is not sold. Instead, it is licensed for use. Now, if you're saying, wait a minute, I go to the App Store, sometimes I give them money. If I wanted a powerful desktop version of an Adobe product or a Microsoft product or something, I'd have to give them money. That's right, you give them money. But in exchange for that, you're not buying it. You don't own the software. Instead, in exchange for giving them money, the company grants you a license for use. What's a license? A license is permission to use with restrictions. In general, a license is permission to use or maybe do something subject to certain restrictions. I know you're familiar with this idea. Here in Wisconsin, if you want to go hunting on public land, you cannot just willy-nilly go out and hunt anytime, any place, for anything that you want. In order to legally hunt on public land in the state of Wisconsin, and I'm sure it's the same for California, you must obtain a hunting license. Now, if you are a hunter, you know, when you get a hunting license, that doesn't allow you to do anything you want. There is a specific season. In Wisconsin, there is a gun deer season. It usually falls around Thanksgiving time. There's a 10-day period where you can, if you have a hunting license, legally go out into public lands in northern Wisconsin and shoot deer. The other thing that license says is, how many can you do? Can I shoot as many deer as I? No, you can't. There's a limit. So the license gives you permission to hunt subject to certain restrictions: where, when, and how. Even if you don't have a hunting license, you probably have a driver license. It sounds so funny to me. Wisconsin calls this thing a driver license. Do you have a California driver's license? I've always said driver's license. I mean, it sounds like it should be possessive. Driver's license. I wonder what it says on there. Guess we'll have to look that up. If you have a driver license, then what? The state has given you permission to operate a motor vehicle on the public roads of the state, subject to certain conditions, like obey the posted speed limit, don't pass people on the right shoulder, don't hit old profs in the crosswalk. All kinds of restrictions, right? Yeah. Yes, you paid money for it, but that does not mean you own the road. Yuck, yuck, yuck. License, familiar concept. So guess what? Software is also licensed. And I think you know, the license for software, the restrictions concern these two things. Think of them together. They're not separate. The restrictions concern copying and distribution. The restrictions on software concern copying and distribution. Makes sense, right? If the end user makes copies of it and distributes it to other people, then the company will not earn money. And I don't know about you, but when I was a professional software engineer working in industry, I liked being paid. And the company can't pay its employees if nobody pays for the product. So software companies are concerned with users distributing their software. It's not copying. We'll see later, you have to copy it to use it. But it's really the copying and distribution that's the problem. And I think you know that. To make it clear, think of it this way. Oh, yeah, my abbreviations, this is hardware, sorry. Is hardware licensed or sold? You don't even think about computer hardware. Oh, I'm sure. Do you have Best Buy stores, physical brick and mortar stores in California anymore? We do here in Wisconsin. Best Buy. I think they're a national chain, right? Okay. Everybody's shaking their heads. No, nobody's awake. All right, I'll just assume we've got those. I pick on Best Buy. Best Buy is a weird place. You know, you can walk into Best Buy and you could purchase. I picked this toaster from their website because it said this was a digital toaster. I don't know what that means, but that's cool. Do you know you could go into Best Buy and you could buy a toaster, a piece of hardware, and a piece of software at the same time? That's weird. Is hardware licensed or sold? Answer, it's sold. Well, wait a minute. Who's the company? Cuisinart. Isn't Cuisinart afraid that you might copy their toaster? Not really, right? Not really. Anybody who's ever tried to do this realizes how difficult it is. And if you were copying somebody else's toaster to make your own toaster, it would cost you more in parts than it would to just buy a new toaster outright. There's no such thing as a hardware copy machine. Please don't talk about 3D printers. We're not there yet. That matter duplicator on the Starship Enterprise, no, those things don't really exist. There's no such thing as a hardware copy machine. But there is such a thing as a software copy machine. As a matter of fact, you all own one. As a matter of fact, you're using one right now. Software copy machines, they're called computers. All right, let's cut to the chase. Why is software licensed instead of sold? Technically, it is very easy to copy. Software is not physical. Software is informational. Technically, it's very easy to copy software. As a matter of fact, software is designed to be copied. If you couldn't copy it, you couldn't use it. The first step in executing software is the software has to be loaded, copied from storage, put into memory. If you couldn't copy software, you couldn't use it. So it's not the copy that's the deal. It's the distribution that's the deal. All right. So thinking about a software license, how are you going to do that? Most of you are aware there are different kinds of license. A restrictive license, like Adobe and Microsoft have. And then there are more open licenses. And then there are some actually freemium plans and other kinds of things. Regardless, the point is you got to think about this. Something needs to be planned. And if you've ever actually looked at a license agreement, and I would encourage you to do so, but wow, there's a lot of words there. You bet. You bet. All very important words too. All right. What about a delivery date? Likely you're going to pre-announce this, right? Like every game manufacturer since day one. And hopefully, unlike every game manufacturer from day one, you will actually meet your delivery date rather than having pushed out months or years beyond it. Well, it's just one other thing to consider and plan. Payment terms. You're saying, what do you mean payment terms? It's $1.99 at the App Store. Well, no, not all software. Opportunity-based software, contractual-based software, not unusual. When I worked at Hewlett-Packard, we sold some stuff that was millions of dollars. Oftentimes, companies don't want to immediately pay millions of dollars for their software. So you've got to have some kind of terms and payment plan. Whoa, what about a warranty? Will you provide one? Well, you have an option if you're doing the opportunity model. In the opportunity model, you're just putting it out there. You can have a warranty or not. Or you can do the Apple way, even with a warranty, doesn't mean diddly squat. Yeah. But typically, if we're doing the opportunity-based model, if we're doing the problem-solving model, we're contracting this for somebody else, part of the specifications document is the warranty. We warrant this product to be free of defects for whatever period of time. This number 7 relates directly to the final or 6th phase, which is maintenance, but we'll get there. Even with a warranty, what are the limits of liability? If somebody uses your product and something goes wrong, who's liable? If you're creating software for Teslas, and they start running over small children in crosswalks? Who's liable for that? Yeah, and you probably recognize it could be, regardless of what the company says, the courts might adjudicate differently. But lots of things. This is just 8 of dozens of tasks that must happen during software deployment. We'll focus later on, we'll come back. Okay, we did license things, so you know that. But we're going to want to focus on what we mean by production and distribution. Would you read about it today in the notes? And we'll come back and see that a little later in this course. Did you know there's never been a hurricane named Chuck? Because it would have destroyed everything. And not funny if you live in, I did doctoral work at Nova Southeastern University. That's in Fort Lauderdale, Florida. And yeah, hurricanes are not fun. But that's still funny. Zeb, this would be funnier if you knew what an iPod was. You know what an iPod is? Sort of like an iPhone, but it doesn't make phone calls, just plays music. Okay. Zeb, I renamed my iPod the Titanic. See, what the heck? Why'd you do that? Zeb, oh, so when I plug it in, my computer says the Titanic is sinking. 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 I was going to reward you with the opportunity to stand up, but you forgot to laugh at this one. That's okay. It's still important to stand up. Are you ready? If you've been standing up, you can go ahead and sit down for a minute now. But if you've been sitting like I have, go ahead. Synchronize your watches. We got a minute. You ready? Stand up. Oh, darn. Hey. I renamed my iPod the Titanic. Onward. Informatics is a great way to think about computer science. Don't forget the important role that users play. I don't understand why software engineers forget about people. We are people, but they're actual living, breathing human beings that use our products. At the very beginning of this class, when we talked about all the different kinds of management that needs to go on in software engineering, one thing I mentioned briefly and never explained is we have to manage expectations. What are people thinking? We don't want either other software engineers or our clients and users to have incorrect expectations of our product. One way to think about expectations is to go back to these transcendentals of truth, beauty, and goodness. Even if it's not in the contract, users expect truthful apps, accurate. You're making me an app to add numbers. It didn't add numbers. Well, I never said it would. Oh, come on. An app to add numbers needs to accurately add numbers. Hey, these colors are red and green, and a large majority of the population have red-green color blindness. Well, you never said that it needed. The user has a right to expect a level of beauty in the application and goodness. The user has a right to expect that we defined goodness before as efficiency and robustness. Even if it wasn't explicit, the user types in 2 values on your app, presses go, and has to wait 30 seconds for the answer. And the software engineer's response is, well, it did it. Yeah, come on. Users, even if it's not stated, have certain expectations about the product. The 2 concepts that computers are supposed to provide, and these are just classic standard user expectations of apps, is productivity and efficiency. Productivity is a measure of speed, quantity. Efficiency is a measure of quality. How effective is the product? How fast is the product? Okay. I don't share too many stories about me, but I'm going to share a story about me. In a prior life, I was program manager for LaserJet printers. This is one of the things I worked on, the HP 2680 laser printing system. And I was extremely disappointed. You see that huge thing? See this thing here? Not the models, but see it? That's the printer. That's a laser printer. Circa second half of the 20th century. Today, of course, we find those things in a device that's the size much smaller than a microwave oven. All right. Oh, you know what? The other thing that I found somewhat disappointing is at one time I was told as project manager, I was going to be on some of the marketing brochures. I didn't. This is a male model. Now, this person I can understand. This was Miss Idaho. Okay, so I understand this one here, but this one here, I mean, come on. I mean, I'm at least as good. All right, sorry, get to the point, mister. We had a task to do, a maintenance task on the HP 2680 laser printer system. We had a number of large clients that loved the product, but wanted it to do something different. In order to do the different thing, we had to do some multiplication. Say, what's the big deal? Well, this is the second half of the 20th century. It was a custom chip that controlled this thing, and it only did originally what the specification said, and it could add, but the CPU inside this system had no native multiply instruction. Well, I bet you can figure out how to multiply without a multiply instruction. You know that multiplication is really just repeated addition. 3 times 9 is just 9 plus 9 plus 9. I can get the correct answer of 27 by adding and not necessarily multiplying. So part of the specifications for the change to the system involves some multiplication. And the original engineers that signed off on that and said, no problem, did not realize that our machine didn't have a native multiply instruction. Again, they said, no problem, we'll just do repeated addition. But there was a problem because repeated addition could take an unknown number of clock cycles. And we needed to have things done quickly. And there's lots of other processing that was happening every clock cycle. Yowza. Okay. Well, to make the long story short, our team was able to figure out a way to do fast multiplication in the limits of addition in order to meet the specifications. What's this story have to do with software engineers in general? The user had an expectation. The problem could have been solved with simply by repeated addition, but that would have slowed things down. That would have caused the laser printer to pause every second page. Well, suddenly you weren't getting things that were fast, were you? No. Oops. Ooh, what happened there? Okay. That's also my lead into something that I do want to discuss. Talked about this, I think it was last week when we saw that in one of these articles, things software engineers should know. And one of them was big O notation. And I absolutely agree. I hope that somewhere in the curriculum, you'll investigate this in more depth. This is our introduction to it. I like this stuff because I teach the senior theory course, and there's a lot of funny stuff like this in it. What is big O notation? The O here stands for the word order. The purpose of determining the order of an algorithm is to compare two or more algorithms in time and space complexity. We want to compare two algorithms in either time, how fast they can compute, or space, how much memory they require. For example, let's say we needed to sort a bunch of records. There are a number of different sorting algorithms. You may have wondered, why? Here are just three, and there are lots of other ones too. Bubble, you may have, it goes by different names, which I don't recall at the moment because I always call it a bubble sort. Bubble sort is likely the first sorting technique that you learned because although it is not efficient, it is easy to understand, and it employs a nested loop, and those are always good things to understand. Okay. So of these sorts, which is better? Bubble, shell, quick, etc. Well, bubble sort. Did you know that there is a National Institute of Standards and Technology reference for algorithms? It's called the Dictionary of Algorithms and Data Structures, DADS. I'm going to go there. Sort by comparing each adjacent pair of items in the list in turn, swapping the items necessary, repeating the pass through the list until no swaps are done. Yes. Also known as syncing sort, exchange sort. Yeah. Complexity is order n squared. I'm sorry, I really have to do this. There are these cool things where folks have put algorithms to Hungarian folk dances. No joke. Well, yes, I know you want me to do this into the completion, but you can see what's happening. You're going to go through the list, comparing the adjacent items. If they are in order, leave them. If they're out of order, swap them. And then you go through the list again and again and again. For a list that is sufficiently badly ordered, the time complexity approaches n squared. I'll mention what that really might mean in a moment. Oh, we're not going to do the other one, but you've seen bubble sorts? Code for bubble sorts? Good. Bubble sort is the simplest to understand sorting technique, and it's also the slowest sorting technique. This order n squared, what does that mean? Well, first of all, here's the code, or one way to implement the code. What you notice about the implementation is the idea of a nested loop, a loop within a loop. Outer loop runs approximately n times. The inner loop runs approximately n times, with n being the number of elements in the list to sort. So yeah, if there's only 10, it's for every iteration of the outer, the inner runs 10, so it's 10 times 10, 100 times. That's the n squared idea. When computer scientists want to evaluate competing algorithms or possible algorithms, they're going to investigate and determine the time complexity of that algorithm. How that's done is beyond the scope of software engineering. It is entirely within the scope of a theory class. But that's okay. You don't even have to take my word. You saw it there on the official Dictionary of Algorithms and Data Structures that the time complexity is order n squared. Now, I can use that and I can compare the time complexity of this sort to the time complexity of another different sort. There is a sort called quicksort. C.A.R. Tony Hoare, the computer scientist who created it. By the way, the coolest thing, my secret desire is to be knighted by the Queen of England. Oops, too late now. Do I really want to be knighted by Charles? Let me think about that. My secret desire until recently was to be knighted by the Queen of England. When you're knighted by the Queen, then you have the title, Sir. I found out something horrible when I investigated. You know, only British citizens can be knighted by the Queen. Darn. So anyway, Tony Hoare, British subject, is the inventor of a sort called quicksort. You want to guess why it's called quicksort? Because it's quick. Can you see the little GIF graphic here? Yeah. The idea is you sort by recursively partitioning the list. And then you sort that. It's harder to understand because it deals with recursion. And when we're learning computer science, recursion is a horrible thing. But it's a very fast technique. How fast, you ask? Oh, glad you asked. Picking up from the array, the pivot, partition ring, generalization, I am a kind. Quicksort has a running time order n squared in the absolute worst case, which is true. But it typically has order n log n. We'll see it. Okay. You really want to watch this, don't you? I don't blame you. Not bubble sort, quick sort. Actually, this is a really understandable way of considering quick sort. Music's a little better too. We got to get somewhere and then we'll stop. All right. There's your day off assignment. You can watch all these Hungarian folk dances dealing with algorithms and data structures. Oh, it went away. Oh, well. How about that? There we go. Quicksort is usually thought of to have this time complexity, order n log n. Now, you're wondering which one of these is better, n squared or n log n? Oh, okay. Yeah. I was going to show you that one, but I've changed my mind. Resume share. Did it do it? Is it sharing the right thing? Whoever knows what Zoom is up to. Good. So, question, which sort is better? Quick sort, order n log n, or bubble sort, order n squared. By the way, when computer scientists talk about log, we don't usually use base 10 or base E. We usually use base 2. It's not even there because it's always inferred. Quicksort is order n log base 2 of n. Well, what's that mean? Well, let's use a representative value. Let's say we need to sort 1,000,000 elements. N log n means 20 million, whereas n squared means 1 trillion. A trillion is many more orders of magnitude bigger than 1,000,000. Yeah. Suddenly, that's some real time. So as software engineers, we need to consider what's the time things are going to take. That's an expectation of the user, regardless of whether we explicitly listed it in our specifications or not. Users are not going to wait for 15 seconds for an app to do something on their phone. It's not going to happen. This chart could be much better, but the only thing it's pointing out is some things are good and other things are not as good. So here in the red, not very good, horrible area, you see order n squared. And although the quicksort is in this bad area, it is orders of magnitude better than a bubble sort. Well, of course, things that are order n would be fair, and less than that would be really good. But there's no sorting algorithm that approaches either of these here. So we look at the spectrum, we say, I got this, that's really good. Big O notation used to compare algorithms in time and space complexity. There's another expectation that clients have, users have, and that's scalability. What's scalability, you have asked? Well, let's define it by seeing a scenario. What happens when many more resources are used? What happens to the productivity and efficiency of your app when many more resources are used? What's a resource? Could be many more data items, could be many more users, concurrent processes, whatever. What happens when many more resources are used? Oh, you know what? Before we do that, classic example. You have an e-commerce website, and typically you get, I don't know, pick a value, 10,000 hits an hour. But it's Black Friday. Your marketing crew has said, hey, get a, I don't know what would be a cool thing to get? I don't know. Get this next generation gaming console for a third of the manufacturer's suggested retail price, which of course can't happen because all gaming manufacturers tightly control what they're sold for, right? But anyway, just pretend. You see that, and you and 100 million other people go nuts, and you go to the website, and guess what happens to the website? The site that's used to having 10,000 hits per hour now suddenly has 100,000 hits per second. Yes, it grinds to a halt. Why? Because it wasn't scalable. A system is considered scalable when it doesn't need to be redesigned to maintain effective performance during or after a steep increase in workload. Now, if you say, oh yeah, I see what's wrong with my e-commerce website, I'm just going to go and change. Well, no, that doesn't count. A scalable system doesn't need to be redesigned. Now, you may need to add additional processors or additional storage or additional datacom lines or something, but you can do that, and that same system will now be able to work efficiently. A system is considered scalable. It doesn't need to be redesigned to maintain effective performance during or after a steep increase in workload. Trying to find good online videos of what a software engineer does, really, really hard. I usually like to invite in former students, but trying to get the time arranged is also hard. And I don't blame anybody. Nobody wants to sit down and create a video either. I can't blame people. So we'll look at part of this one. Feel free to peruse online, but I'm just I'm going to jump to the end. I'm going to tell, no. In general, I like this guy. I'm going to just skip a couple ads here before I go by. Like you, I think we're all tired of getting texts on our phones that ask us to vote for a certain person. Come on, are you going to skip by here? Maybe not. Maybe we've got to actually play this one for a minute to get it to skip. Nope, skip ad. Good.
In this video, we're just
software engineers do, and we're starting
Where'd it go?
right now. Hey, 1% Nation, I'm Jake Voorhees, and you are watching the 1%.
Okay. Do I have this set? Can you really see it? Well, if you can't
Engineer Show, where we
Shout it
empower
out.
young engineers to rise to the top 1% of their career. So if you want to be a successful engineer, make sure you subscribe and hit the bell. There's lots of good stuff in the
I don't believe it.
I am just hearing the audio.
Thank you. Thank you. Yep. I never believe what my status bar on Zoom says. Participants can now see your application. Okay, we'll try this.
Description below, the Discord server, the free 1% engineer kit, the link to our new IG page. So make sure you check out the description of this video, guys. Software engineering gets searched more than any other type of engineering field because there's such a large demand for anything programming, data analytics, all of those being under the umbrella of computer science. So let's get right into the video, guys. Software engineering is the systematic application of scientific and technological knowledge, methods, and experience applied to the design, implementation, testing, and documentation of software. In short, software engineering is the application and development
I like
of
our
software.
definition better, but that's fine. That was a very textbooky definition. That's fine.
Software engineering is a branch of computer science. In fact, guys, software engineering is just a tiny branch of the CS industry. Computer science is more of a study of the processes of how we use and interact with our data in the form of programs. CS professionals use and develop algorithms to manage, save, transfer, communicate, and understand data or any sort of digitally coded information. Because of this, computer scientists study more of the theory of computation and the design of software systems, rather than the creation of the actual software or application itself. Who wants to be a software engineer? Let me know why this is the engineering type for you. Leave a comment below. Now that we've briefly covered the differences between overarching CS and software engineering, let's get into a little history. In the 1950s, computer programming languages were starting to emerge, which was massive progress. Fortran, for example, an ancient language that I recognize is one of these early languages. In the beginning, the term software engineering started to be used in the 1960s. There was a conference that NATO held in 1968, and in 2018, the conference celebrated 50 years of software engineering. So this field is only 50 years old at best. And here we are in an era where there are tons of coding boot camps and people can become software engineers with essentially no institutionalized training. You can teach yourself everything. In fact, some of the best coders have. So it's really interesting as to where the industry will go. A lot of people speculate that coding is the next coal mining. There's such a boom for people in that industry that there will be no jobs available one day. We will see. And a lot of people talk about the fact that AI and machine learning is actually going to write software much better than humans ever will. But for now, this industry is ripping. It's in high demand, and it's a pretty safe avenue to approach if you are interested in anything coding, programming, and actually want to be an engineer within this field and build stuff, make stuff, create stuff. With that being said, guys, now let's talk about the subfields of software engineering. All primary engineering lanes have several branches or subfields within them. Software engineering has 4. Field number 1, applications development and product engineering. This is problem-based, non-web-based software development that includes programming language such as Java and C++. In order to understand this specific subfield a little better, I want to point out a software engineering YouTuber that I love, Mayuko, where she was in this video with the top 10 engineering YouTube channel.
What?
Why should you use Miro?
Orion.
When you draw on a whiteboard, no one sees it. With Miro, you plan together in real time from literally everywhere. And it's not just a board, it's an infinite canvas where you visualize ideas.
Channels that I made 2 years ago, who works on mobile apps, is a product engineer and product manager, who is the head of the product process. She talks about her work as she gets to hand things over to the designer who works out the look, and then how she's the software engineer who actually builds the projects that she works on. She says the role is very collaborative, they get to make decisions as a team, and the entire process can happen super fast. Sometimes a new product comes out in just a few weeks. So it's very exciting, it's very dynamic, it's very agile, very flexible, very innovative. This is what software engineers do. She says that about 20% of her time is spent working within the team and collaborating and coordinating with the project manager. About 70% of her time is actually spent building the product. She works out a plan based on discussions with the team, asks questions like, do I need to coordinate with other teams in the company? How am I going to format the data and express it in a way that I want, and so on. The final 10% of her time, she says, is spent doing random things around the company. Subfield number 2 is systems development. Systems development engineers design and code the background software created to support application development, which includes programming languages like C and C++. There's another video by a software engineer named Forrest Knight that I really like, whose channel is all about his experience in this type of role, so go ahead and check it out. Especially in his What I Do as a Software Engineer video, where he expresses even more flexibility on the job than Mayuko does, even though she has a great situation too. The company he's with is more like an actual startup, where it seems much smaller, and he talks about setting up alerts for content as he manages some of the social media, and does a series of other things for such a small company. This is a very common thing, guys. Think about massive brands we know of today like Instagram, which in only 500 days of production and 11 people sold the company for $1 billion. There were people doing all types of different tasks. So if you find yourself a part of a startup team, just like I have at Nerd It Now, then you might be doing a variety of things. The third subfield is web development. These engineers design software applications to run in a web browser and use programming language like HTML, JavaScript, and PHP. I really like this video of a day in the life of a web developer, a YouTuber that I follow named Chris. He used to work in code for Entrepreneur Magazine, so check out his channel for sure, where he explores a little bit of what it's like to be a web development engineer. The third subfield is an embedded systems development engineer. Embedded software engineering is the process of controlling various devices and machines that are different from traditional computers, all using software engineering. Integrated software engineering with non-computer devices leads to the formation of embedded systems. Embedded systems are typically popular in medical science, consumer electronics, manufacturing science, aviation, and automotive technology. Okay, now that you understand the 4 subfields within software engineering, let's talk about the different type of software engineering roles that you could find yourself in.
I'm going to skip ahead to the work environment thing. I thought it was, really? Is it all the way here? Okay.
So now that you know the 4 subfields and you know 6 core types of roles within software engineering, let's talk a little bit about the work environment. Just like many engineering fields, software engineers can work pretty much anywhere. There's a huge demand for them in the actual web development and application space. All of these platforms have their own team. All of these companies that have their own web portals or applications have their own software developers who are constantly working on improvements and new versions and maybe even fully new products within their software suite. You also have a lot of software engineers who get hired for big business like the financial industry and the energy sector and insurance sectors, along with all massive Fortune 500 companies who code their own customer relationship management systems, their own file sharing systems. They need a team to develop all of their own internal web applications so they don't have to use things like Google Drive, Dropbox. They don't have to use a web client. Everything is safe and secure, and they need software engineers to build all of these things for them. As we saw from Forrest Knight's channel, software engineers can also find themselves working for a very small team. You can have someone who creates their own company with just one person, or maybe even a co-founder situation and a small team like the Instagram story. It's also very common for software engineers to be hired remotely and never even meet the people that they're working with or consulting with or doing a project for.
A little bit of background there. Maybe it's helpful. All righty. So we've pushed it all the way up to the end here. So I'm going to ask you to be sure that you meet as a team. If you're a member of a team, be sure to meet with the rest of the folks. The first person identified on that list is the quasi-team leader. If you'd rather advocate that, that'd be fine, but be sure somebody on here is the team lead. If you're having trouble finding a time to meet, or if somebody is not meeting well, please let me know. It's very important that we do this together as a team. Thank you. So you've got some things to do. You should, before you get too far away, you should, certainly before Wednesday, when you're not doing anything, you should decide when you're going to meet to work on these next assignments, 19 and 20. All right. I'm going to hang around after I cut the recording here in just a second. So if you have questions or comments or concerns, I'd be happy to take them. Otherwise, thanks so much for joining me today. I appreciate your rapt attention. We are not meeting Wednesday, so the next time we'll officially see each other is a week from today. Have a nice day. Have a great Veterans Day off. I'll see you next Monday.